Okay, moving on to question 1. 1a, every whole number is an integer. Well, this is true. Remember your whole numbers are 0, 1, 2, 3, keeps on going. Your integer, in math, we can use the double bar set to represent integer. Integer is just including all the negatives, right? So just the whole number and all the negatives. This is why all the whole numbers, the 0, 1, 2, 3, all these whole numbers can also be called an integer. So this is true. B, every integer is a natural number. So integer, -3, -2, -1, 0, 1, 2, 3, keeps on going. And natural numbers are the counting numbers, so just 1, 2, 3. And then keeps on going. So we can see that this is false, right? Because all the negative integers and the 0, they are not a natural number. So not every integer is a natural number. So -3 is not a natural number. Right? I just need one example that this is false. Then I can say that this is false. C, every integer is a whole number. Again, that would be false because, for example, -4 is not a whole number. And then D, irrational numbers are non-repeating and non-terminating decimals. Yeah, that's correct. That's the definition of irrational number. So that's true. Irrational numbers are real. That's also true. They are all real. Every rational number can be written as a fraction. That's true. That's the definition of a rational number. Right? Rational number can be expressed as a fraction. Every integer can be written as a fraction, therefore every integer is a rational number. That's also true. You can put any integer over 1, like 3 over 1. Every rational number is a whole number. That would be false. The reason why it's false is because 2 over 3 is rational, but it is not a whole number. That's why this is false. Every natural number is whole. Yes, that's correct. All the natural numbers are 1, 2, 3, keeps on going. And the whole number is just including the 0, right? So yes, all the natural numbers would also be considered as whole numbers. J, there are more rational number than irrational number. Well, we don't know that. So this would be false. Think about that. Rational numbers. Let's say just rational numbers in between 1 and 2. Right? You can say that, well, 1.1 is in between 1 and 2 and it's rational because the decimal stops. Another person can say 1.11, another person can say 1.11. So it's never ending. So we have an infinite amount of rational number. And you can make the same argument for irrational numbers. Remember, irrational number is just any imperfect square roots are also irrational numbers. So I could just say, any number in between the square root of 30 and the square root of 35, right? They will all be irrational. So I can say 30.1, another person can say 30.01, and then, it's again a never-ending problem. So because we have an infinite amount of rational and irrational number, we don't know which one has more. Okay. The infinite amount of real number between any two different real number, that's true. Just what we talk about. Right? In between any two real numbers, we can have an infinite amount of real numbers in between them. And then L. Rational number plus an irrational number is always an irrational number. That would be true. A rational number like 2 irrational, right? Like 1.1213 keeps on going, right? Irrational, it must be it must have a non-repeating and non-terminating decimals, right? So if you add it up, you get 3.1213 keeps on going. So that's irrational. And this is why this is true. M is a little bit tricky. We have an irrational number like the square root of 2 times another irrational number like the square of 2. Remember, we can multiply them together, and then square of 2 times 2 is the square of 4, and we get 2, and 2 is rational. So irrational times irrational can be rational. So this would be false. Okay, that's the end of question 1. I'll see you in question 2.